Hey, this is the last video about hypothesis testing. This one is for proportion. So just like the last video, it should be pretty quick because you already know all the details about hypothesis testing. We just have to fine tune the proportion part. So to start off, we have a medical billing specialist who would like to test the claim. And then here's the claim that the proportion of patients with a high deductible health plan who have overdue medical bills is greater than 59%. That is a long claim. They sampled 80 patients, so there's my N, and determined the sample percentage, that's my P hat, to be 70%, and then there is alpha. Okay, so we have our null and alternative hypothesis here, and this time it's P, because you heard me complaining in all the last videos. I like this one better. So they're both P, and here for the sample, for the claim, we have that it's greater than 59%, so greater than 0.59. Don't forget that for all of these with proportion. So remember I said this in the confidence interval video. This symbol, that means percent. Proportion is this decimal right here. So they go together, but when they give you a percent, we want to write it as a decimal between 0 and 1. And so then the null would be P is equal to 0.59. Okay, so let's draw a picture using a P value of 0.023. So here we have our P is, okay, let's be clear here. This is P for proportion. This is P value, which is, I don't even know the history behind p-value. That's just what it's called. It's not the same as proportion. We need the p-value and the alpha. But what I was trying to say over here, P is greater than, which tells us that this is a right-tailed test because greater than is right-tailed. Hopefully you're getting, let's see, I was trying to move that over, but let's just undo it altogether, make it a little more dramatic. Here's our right-tailed test. So that way we have some room to shade in. Okay, and here, as a reminder, when we're talking about our P, hang on a second, I have to go stop something. So I'm just going to pause it and you won't even know that I'm gone. I will break up the fighting. All right, I am back. All is right with the world. I will be less distracted. No more fighting in my house. And so here we go. We have our p-value of 0.023, and we have our alpha of 0.05. And so as a reminder, our alpha here. And then we're trying to decide if the p-value, which side it goes on. And so when the p-value is less than alpha, then we will reject the null. So that means it is over here. And I just kind of say, where's the shape that I'm looking for? I just kind of say this less than greater than stuff with the p-value. I don't really need you to memorize it because once we get into the calculator will just show you which side it's on. And that's, I'm not a fan of memorizing rules, in case you haven't figured that out. So this is where our p-value is. So we will reject the null because our p-value is less than alpha. Okay, so we are rejecting the null, lowercase, and when we are rejecting the null, then we are, I'm being so particular, but I don't like it when it's a big O. Okay, when we reject the null, that means there is sufficient evidence to support the claim that, now can I abbreviate this? That patients with overdue medical bills, the proportion of patients with overdue medical bills is greater than 59%. So I didn't make it too short, but I did I erased the whole high deductible health plan. But anyways, because we are rejecting the null, that means there is sufficient evidence to support the claim, and then we just rewrite the claim. It's greater than 59%. Okay, one more time, and then we'll start using the calculator. And so it says the nurse would like to test the claim that the percentage of male adults visiting the doctor's offices who has a 2.31 BMI is less than 42%. So don't be tricked by this BMI right here. We don't need it. That's just a number that is involved in the problem. But we do see for this example that the sample is 60 and the percent is the p hat is going to be 40%. That's p hat when we get to it. And then we'll talk about how to type that in with the X and the N and whatnot. And then finally, we have the alpha. So our hypotheses are the null, I'll just write it all out at once, is equal to, so it is equal to the percent in our claim written as a decimal, and the alternative is less than, so P is less than the number given in the claim, less than 0.42, written as a proportion. Okay, so less than tells us that we are using, oh, did I mess it up? Do this every time. Okay, less than tells us we're using a left-tailed test. I'm messing up less than I was in the first video. I got my lines on top of my graph. Okay, so alpha is here, 0.10. And since the P value, which is right here, let me just be clear. This is the P value that we're comparing it to. Since the P value is greater than alpha, then we are over here. Oh, where's my check mark? Somewhere over here is our P value. Which means we will fail to reject the null. Okay, so down here we say fail to reject the null. And what is our conclusion? Extra space. Well, fail to reject, that's how I used to say it. In this section, we're saying do not reject the null. I like this better. I used to say fail to reject. And if you hear me say it, sometimes I say it and I don't realize it because that's how I used to teach this. But I like the wording do not reject the null. It means the same thing, fail to or to do not, to do something. But I like the do not because then it has the not in it. So then I can say there is not sufficient evidence. See how the knots go together? It's just easier to connect the dots. Evidence to support the claim that the percentage of males visiting have a BMI, oh, I guess it's specifically that 23.1 BMI is less than 42%. I was trying to cut it down, but I cut it down a little too much. That didn't make sense. It was the English part. So you can cut it down. It doesn't have to be exactly, I didn't put doctor's office, but you know, very similar. Again, you've probably already seen this in chapter 8. You're not writing this all out yourself from scratch. You're just matching it up. So for these notes, if it's not perfectly worded, that's fine. It's really the there is versus there is not that to get the hang of, and then what the claim is. Okay, so if you were kind of confused on the p-value, don't even worry, because we are going to just start from the beginning and just do the whole program or the whole problem in the calculator to see the picture. Okay, so we have a quality control technician working in a factory. Each day they randomly select monitors and test them. Okay, over the course of a month, they tested 200 monitors. So there's my N, and 12 of them had dead pixels. That's our X. The technician conducts a hypothesis test at the 10% significance level to test whether the true proportion of monitors, okay, and then here's our claim. The true proportion of monitors with dead pixels is greater than 4%. The reason I picked this one is that 4%, and I'll show you what I'm talking about when we get there. Actually, here we are there because that is the claim. I didn't really see a claim at the top, and so I just figured I would wait and see how it goes. And then as soon as I saw that is greater than, I was like, there's my claim. So here we go. Our alternative, no, our null is going to be P is equal to 4%. Why did I pick this one? Because people write 4% incorrectly all the time. And if you write it incorrectly here, you will write it incorrectly in your calculator and you'll get the wrong answer. 4% is 0.04. You move the decimal over 2 times. A lot of people like to put 0.4, which is actually 40%. So it has to be 0.04. 4%, think of it as like 4 cents. That's how you write 4 cents. Okay, alternative, P is greater than or same 4%. Okay, so here's our picture. Greater than means right-tailed. I don't even know if I did two-tailed in this because we saw that in others. I was just trying to get a variety. I really just wanted to focus on what P meant versus mu. Okay, so this is right-tailed. Two-tailed will follow the same pattern. And we are at 10%. Our alpha is 10%. Okay, so let's see where our p-value is on our calculator. So we're going to go down to inference. This is the same as the other section. Test. Now we stay here at one proportion, and we don't have to make a choice because proportion is always z, only z. So I will write my null and alternative just like we did with the mu. So this is 4%, and this is greater than, perfect. Okay, now X is 12. Because X is the number of successes, and it says it right here in case you forget. This is exactly the same as chapter 8. And then N is the sample size. It's the total number they tested or the total in the sample. So this is 200. And then the significance level says it's 10%. Again, that has to be written as a decimal. I did another video, I think the beginning of chapter 8, to say what happens if you don't write it as a percent, it gives you an error. So, I mean, if you do write it as a percent, you want to write it as a proportion. Dang, all these P words go together and it just messes me up when I'm talking. Okay, here we go. So there is our P hat. In another problem up here, they gave us P hat. But down here, we calculated it 12 out of 200. There's our Z, and there is our p-value. So let's see how that works. So notice the p-value is smaller than alpha. So let's see how that is on our picture. Zooming in, we can see that our alpha line is right here. And then the p-value doesn't start till over there. So we can just say over in this section is where our p-value is. And because it is over there in the reject region, we will reject the null. Perfect. Okay, these are kind of spaced weird because I couldn't get these to line up. Like, see how these are over here. So anyways, there's a little extra space over here. So we are rejecting the null, which means there is sufficient evidence. We don't have any knots in this, so there is sufficient evidence to support the claim that, what is the claim? The proportion, you can write true or not true, it's fine, of monitors with dead pixels is greater than 4%. Now, we've talked about this before, but success in statistics does not necessarily mean success in real life. So here, we are looking for dead pixels. Now, in real life, if you have dead pixels, you have a messed up monitor, that's junk. We want to throw that away. Or I'm pretending I know a lot about monitors. But anyways, dead sounds bad. So dead pixels. But here in statistics land, since that's what we're looking for, anytime you find a dead one, we're like, oh, we found one, that's a success. So when you come over here to X, the number of successes is 12. Okay, perfect. So then let's look at this last example. And this is good because we came across this above, but we didn't really talk about it too much because we weren't actually putting anything into our calculator. So I want to show you what happens when they don't give you X and P hat. Okay, so we have our sentence here. Test. The nurse wants to test the claim that the percentage of female adults visiting a doctor's offices who, what do these people visit these doctor's offices and their BMI? Okay, whatever. There's the claim. They sampled 80 adults and determined the sample percent to be 20%. So they're telling us what P hat is. Okay, that's not really as helpful as they think it is. Okay, and then we have our alpha right here. So less than 35%. Let's get our null and our null and our alternatives. So P null is always equal, and we're talking about 35% in our claim. Our alternative, and P in this example is less than in the alternative in the claim, less than 0.35. Okay, so let's draw our picture. We are less than, so we are left-tailed. Alpha is 0.05. We want to figure out where the p-value is. Okay. Oh, wait. Well, do we need to shade it? You know how to shade it by now, right? And you know that my shading's messy by now. There we go. There's my shading. Okay, where is the p-value? So I'm going to come over here on the calculator, go back to the beginning. I just need to go back as far as that, right? Yeah, because that's too far. So I go and I put in my null, which is 35, and my alternative, which is less than 35. Okay, now this asks for X, N, and alpha. It does not ask for P hat. So they thought they were being all helpful over here with their P hat. They are not. Okay, so X, I don't know. But N, the sample size is 80. What I do know, oh, and I know the alpha. What I do know about the number of successes is 20%. Okay, so it's 20% of 80. So what I can do right here is I can just type in 20% of 80, which means 0.2 times 80. And if we're not sure about that, then we will double check when we get to our p-hat page. Okay, so 20% of 80. It says it's 16. It doesn't say 16 over here, but we're trusting our calculator, but we will confirm. All right, look at that. P-hat is 20%. That's exactly what we wanted. We wanted to force this screen right here to say P-hat is 20%. So I'm going to do that one more time just because some people are like, what sorcery just happened right now? Okay, so because X was unknown, oops, trying to blow everything up. Okay, since X was unknown, all I know is what P-hat is. The way we reverse engineer, since I know P-hat is 20% and it's always of the sample, then we have 20% as a decimal, which is 0.2. And then since we are 20% of 80, then we multiply of means times, and then we put our 80. And notice the 80 still stays down here. And as soon as we toggle off of that, it tells us it's 16. And if you're not confident on that, you just trust it until you go to the next page. And then you see, okay, it is in fact 20. Perfect. There's our P. Our P is super tiny. It's way less than alpha. So we are going to reject, but let's check it out. It's very tiny. Look at that. It's way over. See, it says up here Z was negative 2.8. So Z is over here, but our boundary line is over here. So we are going to reject the null. Lots of rejecting, but when we do not reject, that's when we put the not in the answer. So we reject the null. I can't go down any farther. because why? Because I'm at the last page. So I'll try to write this. No, I'm going to write it up here just so it doesn't mess up anyone that needs the closed captioning. So we will say there is sufficient evidence to support the claim that, and then my claim is the percentage of females at the doctor with having a 28.2 BMI or is, not or, is less than 35. So that is my conclusion. I just wrote it up there just so there's plenty of room for everyone to see it. There is sufficient evidence because we are rejecting the null to support the claim, and then I rewrote the claim. I kind of abbreviated it a little bit just to fit it in. Yay, we are done with hypothesis testing. Haha, just kidding. But we are definitely done with chapter 9. In chapter 11, we are going to do a very specific type of hypothesis testing. So you have that to look forward to. All right, email me if you have any questions, and I will see you in the next video. Bye.